was putting together the agenda, this was supposed to be the carbon capture panel. And everyone I talk to about carbon capture says, no, we don't do that. And to a person. And it's just like, it seems like that's the word that's out of fashion, not quite accurate. But I think, each of you are doing some very interesting things in terms of how we are collecting carbon from the, just collecting carbon. So maybe tell me, if it's not carbon capture, what would you call it? And then talk a little bit about your approach. I'll start with you.
Sure. I have this conversation about terminology all the time, just had it at lunch. So maybe I'll do a quick minute on that. So Arca, we are a carbon dioxide removal company. We are all in the business of capturing carbon. It's not a taboo word. It's just that there is a difference in terminology that has evolved. So traditionally, carbon capture and storage, CCS, or you add utilization in there, CCUS, it has come to refer to a specific set of technologies capturing industrial point source emissions. And the storage component of that is typically geologic storage with injection. And I think Sarah will be able to talk a lot more about that. But as the IPCC and so many others have made abundantly clear, not only do we need to reduce our emissions and capture what we emit, we have to capture more than we emit. And this is when we move into capturing from the atmosphere. And that terminology is leaning towards carbon dioxide removal because it is different. The technologies are super diverse. You can see from the panel up here, both in capture and storage. And it's about addressing the legacy emissions that have been accumulating in our atmosphere for a couple of centuries. So maybe I'll just stop there. We are all capturing carbon, but yeah, so I'll talk about what Arca does. So we're a carbon dioxide removal company. We both capture and store carbon dioxide through a process called carbon mineralization. This is a natural process. It's when certain constituents of rocks or minerals dissolve in water and become available to react with carbon dioxide in the atmosphere. When that happens, a new mineral is created, a carbonate mineral, and that stores that carbon in for geologic timescales. Left on its own, this happens very slowly. So at Arca, what we do is we partner with the mining industry who are already in the business of digging up, pulverizing rock, and putting most of that in waste piles. Those waste piles have a ton of CO2 sequestration potential. And mostly it gets buried and is untapped. So we develop technologies to go out onto those tailings piles and unlock that potential. And what that may look like, we're developing a variety of technologies, but we're gearing up for our first commercial pilot this year. And we're partnering with a robotics company that will deploy autonomous rovers on the tailings, kind of physically manipulating those tailings to optimize the contact with CO2 from the atmosphere. We have monitoring and verification technologies that then measure that, feed into our algorithms, then feed back into our rovers to really maximize the CO2 capture. Meanwhile, in our R&D lab, we're developing treatment techniques to make minerals even more reactive, and that will be really, really key to scaling in the future. But I'll stop there and let Andy talk about it.
Yeah, and just before we move on, so the drones are moving over the filings. What are they? Are they just shaking it up? Are they putting chemicals on it? Like, what are they doing to make them more reactive?
Really, it's just churning. We call it smart churning. So these are robots, rovers that go on the tailings pile, and they are churning up the tailings. And it's not rocket science, but the key is...
It's rock science.
Oh, that's a good one.
It's on camera, too.
But the key is optimizing that efficiency and the CO2 uptake, and that's kind of our secret sauce and bread and butter that we're doing out there.
Very cool. Andy, similar outcome, totally different approach.
That's right. We have a completely different approach to the same problem. We're building large-scale carbon removal facilities, we call them. I like to think of them as renewable carbon refineries because some of you are familiar with the material we make. A lot of people call it biochar. It's a portmanteau of biological charcoal. I like to think of it like quantum carbon. It's actually a negative carbon material. Each ton of this carbon material contains 3 equivalent tons of CO2. So it's a great form of permanent carbon storage. But that's where the story just begins, because once we've removed that carbon from the atmosphere and stored it in the biochar, we can then offer that biochar as a low carbon input to industrial supply chains in a number of industries. So a lot of people are familiar with biochar in agriculture. We're interested in biochar's ability to reduce the carbon intensity of fertilizer products by using less nitrogen, which is an incredibly carbon-intense material and also has really bad emissions once it's applied in the soil, like we've heard about already today. So you can use less nitrogen when coupled with biochar to achieve awesome results in agriculture. It's a great replacement for carbon black in applications like ink and paint. So the story begins with carbon removal, but then it continues to scope 1, 2, and 3 emissions reductions for corporate America, which makes this a really profound carbon removal strategy in our minds. Upstream, by the way, I'll just point out real quickly that we deal with waste streams. So we are kind of recyclers of biomass waste. It comes out of forests, through logging operations and mill operations. It comes out of food waste, comes out of agriculture waste. We take those waste streams that would otherwise decompose or combust, releasing their carbon back up into the atmosphere, we lock it away. So we're dealing with all kinds of waste mitigation challenges in forests, in agriculture, and in municipalities. So that's what we're doing in a nutshell.
And then there's the old-fashioned way of sequestering carbon. You've been studying this for a very long time. What do you think of their approaches, and tell us a little bit about your experience?
Okay, well, I think their approaches are great. We've got a big problem in front of us, and any approach that can scale and can do it cost effectively, we should be pursuing with vigor. There is no silver bullet. We need everything out there. We need to put all great minds to this major problem. You know, when we think about it, the concentration of CO2 in the atmosphere has doubled it's more than 50% greater than it was prior to the Industrial Revolution. And we are still emitting 40 gigatons of CO2 per year through some of our industrial and power processes, as well as the cars and everything that we drive. So the area that I do a lot of work is in traditional point source carbon capture and sequestration. And this involves doing carbon capture at the flue stack. And earlier this morning, we saw some pictures of the flue stacks, capturing it before it's emitted, and then compressing it, transporting it in pipelines, and then storing it in rocks geologically where it makes sense to do so and where it can be safely and securely stored forever. That is proven. We know how to do it. We've been doing it actually since the 70s. It just has a bit of a poor connotation because it is associated with extending the life of fossil fuels. And also historically, when they injected CO2 into these rocks, they would use the CO2 to push more oil and gas out, which seems to not really be solving the problem if you're getting more oil and gas out in the process. Nowadays, though, most of the projects that are being proposed, especially in Europe, but even a lot of the ones, especially in California, but also in the US, are not involving that enhanced oil recovery. So a lot of them are just purely injecting the CO2 either into depleted oil and gas fields, which are very good and safe places to put it because you know they worked to store oil and gas for millions of years, but also into what we call saline reservoirs, which are reservoirs that have basically brines that you could never drink, but have similar characteristics, so you know they're good places to put the CO2.
Yeah, I think that there's a negative connotation about the stacks and storing carbon that way. At the same time, like we have to go to where the carbon's being produced in order to solve the problem. Ignoring the fossil fuel industry would be ignoring one of the biggest problems. And so there's going to need to be innovation there, and it's going to wind up going an even longer way. Similarly, like I think on your website, Arca mentions like we're going to need more mines in the future than we have today. We need the nickel, we need the rare earth metals. All of our electric cars need to be built with these metals. So like there will be mines, and this is a way to make those mines a little bit more carbon neutral and productive.
Yeah, ultimately our goal is to make those mines carbon negative. That is the reality. You said it. So basically moving off of fossil fuels means we're going to be more dependent on the minerals and the raw materials that come from mining. All those batteries, all those solar panels, anything to get us moving towards clean energy is going to require a lot more mineral resources, and that is the reality. What we hope to do at Arca is we want to help those mines produce those metals in a carbon-friendly way, and our goal is to make mines carbon negative. That is what we hope to do.
How are you've talked to a couple of mining companies. How is the reception be? Just culturally, from what you're trying to do, are they receptive to it? Are they open to it?
Oh yeah, they are coming to us. Not just a couple of mines. We have a list of 30, 40 mines that have all contacted us because they need to meet their net zero goals. All of the mines have set their own net zero goals. And so now they need to figure out how to do that. And so that's why we're getting a lot of inbound calls and a lot of excitement from the mining industry to do this. So it's been a pretty exciting place to be right now.
And you've got a pilot coming this year?
That's right. We are gearing up for our first commercial pilot later this year. That will be with a major mining company in Australia.
Very cool. Oh, you wouldn't have said that. On a free call, you wouldn't have said that.
That's right. I got clearance.
So Andy, when we talk about biochar, this is another one of these processes that it winds up being pretty useful stuff. So what is the market for that biochar after it's formed?
Yeah, so historically it was used as a soil amendment. It's got these incredible sorptive properties. Think of it like a coral reef in the soil. You put biochar in the soil, it's pure, stable carbon. Life proliferates. And so it holds water, it holds organics, and it allows you to just create incredibly healthful soil. So really well known in agriculture. But what I want to point out to people is that in addition to burning fossil fuels, we put fossil fuels in almost everything we do. So our clothing, our built environment, in this room, there's no one who's not wearing a fossil fuel derived element on their body, probably, or in the cars you drove, the materials we use every day. So what we're trying to do is invite companies to come to us and say, we have fossil derived inputs in our supply chain. How can your negative carbon material be a replacement input in that supply chain? So for example, we're working with soil companies who are using peat and perlite in their supply chains. We can reduce the carbon footprint by replacing those materials in soil products. In drywall, in cement, in paint, in ink, we can replace a lot of the high carbon intense materials in the supply chain. So if you want to reduce your Scope 3 emissions or even your Scope 1 emissions in your physical environment, we can provide a replacement. The other thing I'll just quickly point out is that when you produce biochar, it's exothermic, so it produces a lot of heat. That heat can be used to produce electricity. So if you want to reduce your Scope 2 emissions, buy power from us, and we can help you in that regard as well. So Scope 1, Scope 2, Scope 3 emissions, all addressed by biochar production, which I think is pretty cool.
Indeed. Sarah, we're going to talk a little bit more about the IRA in a couple of sessions from now, but in terms of that coming online and all the incentives that are built in there, for better or worse, there's incentives for pretty much every industry, including the oil and gas industry. What do you see the impact of that bill being once that money finally starts flowing?
Well, a few things we're starting to see already. First of all, for carbon capture and sequestration, there's one incentive called 45Q. And one thing that the IRA did was increase the value of that incentive. So it used to be that for every ton of CO2 that was geologically stored, you could get $50 per ton. That's up to $85 a ton. And if it's through direct air capture, then it's even higher, almost double that. So that's a huge sort of incentive that is actually spurring a lot of activity right now in the CCS space. But we're also seeing a lot of funding coming out from the Department of Energy, billions of dollars of funding to help get any of these carbon removal projects, both basic technology up through actual helping to with feed studies and actually helping with developing actual projects.
I just wanted to, you may know this, but as far as I know, 45Q doesn't apply to CDR technologies like Bethany's and like ours, which I think is one of the unfortunate parts of some of the policy that's coming out. I mean, no question IRA is a huge boon, but it would be nice to see some reform on
Agreed.
policies like 45Q.
And why was why were those industries excluded, do you think?
I think primarily, Sarah would know more than I do, but it was driven by the fossil fuel industries, and so that point where it could be pushed back down into the wells, the direct air capture carbon for oil recovery and enhancement was one of the key drivers of that incentive. So once again, it was the fossil fuel industry kind of driving the cart.
But to point out that the incentive is higher if there's no enhanced oil recovery involved. If
That's
it's
great.
just pure storage.
And I'd also like to add to those points that the carbon dioxide removal industry is very young. It's an emerging industry. And again, that's another distinction from like the traditional carbon capture and storage industry. There aren't any protocols and standards yet. So it is hard for a regulation to include these other technologies when the standards don't exist. And so that is a major piece of work that our companies and everyone in the carbon dioxide removal industry is trying to bring up to speed. And yeah.
So it's a young industry. How do you scale it? Like, what do you need in order for each of your businesses to actually scale and reach that sort of the scale that we need?
Yeah, I mean, we heard this morning from Melanie at Microsoft that innovation funds like theirs are helping invest in companies to create new markets and to purchase carbon removal credits as a way of catalyzing those industries. That's incredibly important. I'd say, I think that's one of the things you need for sure. I'd say the other thing we've heard about is MRV, measurement, reporting, and verification. Right now, that's at an incredibly early stage, and if you think about it kind of like the SEC, we need to get to the point where there's just a universally accepted MRV standard across each one of these carbon removal technologies so that investors, frankly, can have the confidence in the technologies to put their money there. And I think that's in its earliest stages right now.
Yeah, that's a great point. That's a great point. And that's another thing we keep hearing is that there's just the measurement standards just aren't there. And therefore, the investment money is being locked up, and then the oversight, and also even just some of the media accounts of like trying to cut through what the actual impact is going to be. Nobody has really firm numbers,
right?
And so those need to come online. So let me ask, in terms of one of the things I was worried about talking about carbon capture and carbon sequestration is like we also still have to keep our eye on the fact that we have to stop generating so much. Period. Like that's still an important issue that we want to make sure we keep front and center. Do you have any advice for how we should go about doing that at scale? Sarah, maybe you can.
How we should stop emitting CO2 to begin with.
Yeah.
Well, drive electric vehicles, things like that. But there are some issues. There are some very hard to abate industries. The steel making industry, the cement making industry, they require very high process heat to do what they need to do to make those products. And it's very hard to electrify those industries or consider alternative fuels for those industries. So we do have some industries that it's just very hard to abate the emissions, and those are industries where the point source carbon capture might make more sense if we want to keep those industries going, which I'm sure we do. The other thing is, there's a big push for renewable fuels and renewable electricity everywhere, solar and wind. But we do have days, and it feels like we've experienced them in California recently, where you have no sunlight for a week. We have had a lot of wind, though, but there are times when you both have no sun and no wind. And if we're relying on renewables and batteries, we may have an issue with whether or not we have enough clean, firm power. And actually, that's something you can do carbon capture retrofits at gas-fired power plants. If you have a few of them in the system, then that does give you potentially a backup if you have one of those extended periods of windless, sunless days.
Got it. We've got time for one question. If I see anybody with their hand up, the mic is ready. I don't see, there's one over there.
Hi, my name is Brigitte. I'm actually a writer and communicator, and my question is that we have heard so much about carbon removal, sequestration, and storage. And I don't know if this is a silly question, but what about methane? Can we mineralize methane?
Well, that is a good question.
Unfortunately, no, the chemistry just doesn't work out, but methane is also a very huge piece of the piece of the problem, and I know that there's lots of other work going on there, but unfortunately not at Arca.
That's unfortunate. Hate to end on a down note.
But we are mineralizing lots of CO2, so we will be.
Oh, we've got a question up front.
Hi, Joyce from the
Joyce.
Voice of Joyce. One question. I hear you talking about mining. I hear you talking about mining. Is anyone doing major recycling of our batteries? Because I read that if you recycle our batteries, we've got enough lithium that we don't need to mine.
Unfortunately, even if we recycle everything that we can, we're still going to need more mining. It's just the scale at which we are going to need to do this clean energy transition, to get everything onto renewables and power and use batteries and store that energy. We're just going to need a lot of raw resources, and that is just the reality. It's kind of mind-boggling.
All right. Well, I think that all these technologies are interesting and will all probably be part of the solution. And let's just hope we can scale it up quickly.
Thank you.
Thank you so much. Thanks
Thank
for
you.
coming.